placed in front of the camera lens in photography in order to darken skies, manage reflections, or suppress glare from the surface of lakes or sea. Since reflections tend to be at least partially linearly polarized, a linear polarizer can be used to change the balance of the light in the photograph. The rotational orientation of the filter is adjusted for the preferred artistic effect. For modern cameras, a circular polarizer is typically used. This comprises firstly a linear polarizer which performs the artistic function just described, followed by a quarter wave plate which converts the now linearly polarized light into circularly polarized light before entering the camera. The additional step of converting the light to circular polarization avoids problems with autofocus and light metering sensors within some cameras, which otherwise may not function reliably with a simple linear polarizer. Usage: light reflected from a non-metallic surface becomes polarized. This effect is maximum at Brewster's angle, about 56 degrees from the vertical for common glass. A polarizer rotated to pass only light polarized in the direction perpendicular to the reflected light will absorb much of it. This absorption allows glare reflected from, for example, a body of water or a road to be much reduced. Reflections from shiny surfaces are also reduced. This allows the natural color and detail of what is beneath to come through. Reflections from a window into a dark interior can be much reduced, allowing it to be seen through. Some of the light coming from the sky is polarized. The electrons in the air molecules cause a scattering of sunlight in all directions. This explains why the sky is not dark during the day. But when looked at from the sides, the light emitted from a specific electron is totally polarized. Hence, a picture taken in a direction at 90 degrees from the sun can take advantage of this polarization. Actually, the effect is visible in a band of 15 degrees to 30 degrees measured from the optimal direction. Use of a polarizing filter, in the correct direction, will filter out the polarized component of skylight, darkening the sky. The landscape below it, and clouds, will be less affected, giving a photograph with a darker and more dramatic sky, and emphasizing the clouds. Perpendicularly incident light waves tend to reduce clarity and saturation of certain colors, which increases haziness. The polarizing lens effectively absorbs these light waves, rendering outdoor scenes crisper with deeper color tones in subject matter such as blue skies, bodies of water and foliage. Much light is differentiated by polarization, e.g.,